In this lesson, we're going to talk about arithmetic sequences. And all a sequence is just a pattern of certain numbers. And so we're looking at one of those specific patterns today. And so in this first problem we have here, we've got a list of numbers, 2, 5, 8, then 11. And so we want to know what pattern do these numbers follow. Okay, that's what we're looking for here. So I know if I go from 2 to 5, I'm adding 3. From 5 to 8, I add 3. 8 to 11, I add 3. So my pattern that I'm following is I'm adding 3 to every term number. So then we could use that to find the next number on the list. If we took 11 and we added 3 to it, well, we'd be at 14. So that would be the next number. And we could keep this pattern going for as long as we wanted to. And so how could we find the 100th number of this list? Well, we now have the first 5 terms, so we would have to keep adding 3 95 more times. So let's just say add 3 95 more times, right? But that would be really boring and inconvenient for us, right? To just keep adding 95 times. And so what sequences do is they allow us to broaden this, this pattern so that we can find specific numbers at different places. So let's write this out here. We're going to say an arithmetic sequence is a sequence of numbers in which a constant is added to each term to produce the next term, which is exactly what we did above. We kept adding 3 and 3 and 3 for however long we wanted to. Now, the constant that we're adding, whatever number is between each term, we're going to call the common difference. Okay, so that's whatever we're adding. We call that the common difference. And we can make an equation to tell us the pattern to find future numbers. So let's build that out. It's going to be a sub n, where n is this smaller number than a down here at the bottom, is equal to whatever that common difference is, times n, which is going to be our number of terms, plus a0. So what does all this stand for? Well, n is going to be the term number that we're dealing with. So if we want the 100th term, we could plug that in for n. It's also the same n that's here. The a is going to tell us our term value. So whatever number we get out, that's going to be our a. That's whatever the value is. Now this d, that stands for our common difference, okay, whatever we're adding or subtracting between our numbers. And lastly, this a0, this 0 is actually the same as the n value, but now we have a specific number that we want. So a0 is going to stand for what we call the 0th term. Okay, so if we think about like this 2 in our first example, 2 is the first term of the sequence. So it's already been added, like 3's already been added to something to get to. So we want to go back and figure out where is this actually starting, and that's our 0th term, we'll say. And so let's go down here and let's do some examples. So this first one, the first 4 terms of a sequence are 11, 9, 7, and 5. So what's going on here? Well, to get from 11 to 9, we're subtracting 2. 9 to 7, we're subtracting 2. 7 to 5, we're subtracting 2. So my common difference is that we're subtracting 2. And so I know my difference now. So my an is going to be negative 2n. And now I need to find that 0th term. And to do that, I'm just going to go in reverse. So if I'm subtracting 2, I'm going to say, okay, well, I get 11 from subtracting 2 from what? So I need to do the opposite and now add 2. 11 plus 2 would give me 13, which would be my 0th term. So my equation, my formula here, is an is equal to negative 2n plus 13. So let's go to this problem with the graph here. when we have a graph like this, we can label our x-axis as our term number because that's our independent variable. We could pick any term number that we want and follow the pattern and see what is that term value going to be at that term number. And so the term value would be our dependent variable, which means it will go on our y-axis. Okay, so now let's figure out all of these points. I see my x-axis is just counting by ones all the way to 10. But my y-axis is counting by fours. I've got -4, -8, -12, -16, -20. So this first point is going to be 1, -20. Then I've got 2, -16. I've got 3, -12. I've got 4, -8. I've got 5, -4. I've got 6, 0. I've got 7, 4, and 8, 8. And so I see that I'm counting by fours here. I'm going -20 to -16 is adding 4. Every time I'm adding 4 each term. So my term value, my common difference, is going to be that +4 times however many terms I want. And now I need to find the 0th term. So if I take -20 and I do the opposite and subtract 20, I'm going to have -20 minus 4, which would be a -24. And so that's my equation, but I also want to show you that when we have these patterns that we're doing, Desmos can actually help us find that pattern and find the equation for us. So to set this up, what I'm going to do is I'm going to click on this plus sign here where I can add an item, and I'm going to add a table. And so I've got my x, which I can call my n, and then the y is going to be my an. And to get the little number, you can do shift and then like the underscore tab right here, which is the same as the minus. And so now I can plug in. I went from 1, 2, 3. I had my first 8 term numbers. And my term values were -20, -16, -12, -8, -4, oops, 4, 0, 4, and 8. And I can click on this button here, and it will show me that looks like the same pattern that I have on my graph. And now if I click this button here that says Add Regression, it's going to come up with an equation. And you see it's the same numbers that we have in our in the formula that we built, just with different letters. So we can change this y to be a sub n, and this x can just become n. So with my last example here, I see that the third term of the sequence, okay, A3, the third term is 13. The fifth term of the sequence is 23. And the seventh term of the sequence is 33. So since my terms are a little more spread out, it's a little bit harder to figure out what that difference is, and especially what that 0th term is. So let's use Desmos to try and solve this. So if I add a table, my third term is 3. Well, sorry, my third term is 13. My fifth term is 23. And my seventh term is 33. And now I can click on this Add Regression button, and it gives me this equation here. And so we want this as an arithmetic sequence. So we're going to say that an is equal to 5n minus 2. So that means my common difference is I'm adding 5 each time, and -2 was my 0th term. So I hope you had as much fun as I did learning about arithmetic sequences. Good luck in your practice, and I'll see you in the next video.